Hi dear students. So in our last class we were discussing about applications of inductive effect. Remember? So the first application, as you could see in the screen, we were discussing that inductive effect can be used to predict the stability of carbocation, and we have seen that how we need to analyze that. Okay. And what was the second application? Okay, the second application was inductive effect can be used to predict the stability of carbanions. And we know that these carbocations or carbanions are all intermediates, reaction intermediates. Reaction intermediates means you know that reactants will get converted into products during a reaction. But reactants will first converted into a reaction intermediate, then the reaction intermediate will convert it to products for some particular reaction. So this intermediate that is formed during a reaction are called reaction intermediates, and the various reaction intermediates are carbocations, carbanions, then free radicals. In addition to that, there are other intermediates, but these three are very important. Okay, so next we will try to see what is the third application of inductive effect. Okay, so let's see. Okay, so the third application I can say as the very important one, another important one. So it can be used, inductive effect can be used to predict the reactivity of alkyl halides. So I can say I effect used to predict what actually used to predict the reactivity of alkyl halides. So you might be knowing in your plus 2 you have the first organic chapter. What you are learning there is haloalkanes and haloaриdes. So the other name of haloalkanes is alkyl halides. So I will give you a general idea how the alkyl halides looks like. So you know that from alkane only usually alkyl halides are made. So for example, you are taking an alkane like CH3. So you know that this is ethane. So from this, if I am removing one hydrogen, okay, so this will become CH3 CH2. Correct? CH3 CH2. This is called, one hydrogen is removed, alkane will become alkyl. Here ethane will become ethyl. So into that I am introducing what? I am introducing a halogen X. This halogen can be anything: fluorine, chlorine, bromine, or iodine. So this will become CH3 CH2X. Okay. So I will just reduce the thickness of the pen. Okay. So I hope you got it. This is alkyl halide. Now I am going to predict the reactivity of the alkyl halides with the inductive effect. So to predict that, I should know how the alkyl halides basically react. Then it is easier for me to say how the inductive effect is going to play an important role here. So let's see that. So I can say that any alkyl halide, for example, the one we have written here, CH3 CH2X. Okay. CH2X. So during the course of the reaction, we know that here all carbon hydrogen bonds are non-polar bond. Why we say it is a non-polar bond? Because carbon and hydrogen have very less difference in electronegativity. That means when the bond is broken, the both electrons one electron will move to the carbon and other electron will move to the hydrogen. But if you have a carbon halogen bond is there, CX bond is there, what is the importance? So in that case, you know that halogens are more electronegative than carbon. So what will happen is when this bond is broken, okay, when this bond is broken during a chemical reaction, halogen has a tendency to attract the electron because it has higher electronegativity. So what will happen? The carbon will lose the shared electron and it will acquire a positive charge. So you will get an intermediate like CH3 CH2 plus, and you will have X minus. Now if you see this intermediate, now you know that this intermediate is a what actually? Carbocation. Now I can say that if this carbocation is stable, then only it can, what will happen? It will stay in the reaction medium. If it is not stable, it will not even this reaction will not even proceed actually. So I can say this is step 1. and it is moving to step 2. Okay, so I can say it will not even proceed from step 1 to step 2 if the carbocation is not stable. Now the question here is, I can say how much more stable this carbocation is. That much easily it can be attacked by a new nucleophile, or it can undergo an elimination reaction to form a product. So this carbocation has two possibilities. Okay, so it can undergo elimination. So if it undergoes elimination, the product will be an alkene. Okay, CH2 double bond CH2. Okay, the other possibility is this can be attacked by anybody who is having a negative charge, because the carbocation has a positive charge. So I can say it can be attacked by a nucleophile with a minus charge. So you will get CH3 CH2 Nu nucleophile. Now the question here is how the elimination happens. I'm not going in detail to mechanism. Elimination happens because of there is an alpha carbon atom that has hydrogen atom, and through hyperconjugation any of the hydrogen can leave as a proton, and that bond will move to this particular carbon and form CH2 double bond CH2. I will come to that later because we have a separate section of classification of different reactions. So just now you know that from carbocation it can form two products. Now the question here is, for this is the step 3. Okay, this is the step 3. Now this can also be step 3. Why? Because it can have two paths. Either of the path will be followed. Now the question here is, you are given a list of alkyl halides. Okay, for example, I am giving you, I will take another color. So you are given different alkyl halides, something like you could see here CH3, 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 and you can see here halogen is connected. This is one. Then you are given another alkyl halide CH3, CH3. Then into that halogen is connected, and you are given a third alkyl halide, something like this, CH3, CH2, CH2, X. This is the third alkyl halide that is given. So you are given 3 alkyl halides, you could see here. Okay. Now the question I am going to put forward is, which among the following alkyl halides will give you a product? It can be either an elimination product or it can be a substituted product, but who will give this very fast? So who is giving very fast means that will react very fast, I can say like that, correct? So I know that the reaction of alkyl halide is following a 3-step process. 3-step process. What is a 3-step process? So this is the reactant first, then the reactant will get converted to reaction intermediate, correct? Then it is forming the product. Now the question here is, you can actually think of 3 steps. Now my question here is, if the second step here is not stable, that means you think like you are jumping from one step to the next step and from next step to the third step. In this case, if the second step is not stable, will you jump from first step to second step? Surely not, correct? So my criteria for saying the reactivity is, I can say if the second step is more stable, then more easily this second step can be converted to third step. So how to say the reactivity of alkyl halides? Very simple. I can say 3 steps. First step is remove the halogen from the given alkyl halide, form the intermediate carbocation, check the stability of the carbocation by any of the mechanisms that you know. It can be inductive effect, it can be resonance, or it can be hyperconjugation, and the priority is resonance, hyperconjugation, and inductive effect. Okay, check with these steps and identify which carbocation is more stable. Then you can say that the carbocation which is more stable, then the alkyl halide corresponding to that carbocation will react very fast to form the product. Okay, so the logic is very simple. The intermediate, that is the reaction intermediate formed during the reaction, should be stable, then only it can be converted to products. So if the reaction intermediate is not stable, means it will not even drive from step 1 to step 2. Okay, so let's see the analysis. So I can say the first one. Okay, so I will go to the first one. So in this first one, you can see here I am removing the halogen, step 1. So you can get something like CH3, CH3, then CH3, you get a carbocation. Now I am going to predict the stability of the carbocation. through inductive effect, since we are learning inductive effect. So I can say CH3 group has what effect? So CH3 group, it has, as you know, it has plus I effect. So here 3CH3 group is actually pushing the electron towards the central carbon, because plus I effect means repel the electrons away from it. So it will repel the electron towards the central positive carbon. So when electrons are coming to the central positive carbon, then there is already plus charge that will get neutralized by the negative charge of the electron. So that means it is getting stabilized. Okay. So once this is more stable, then this can be either undergo elimination, or it can undergo nucleophilic attack. Okay.
RBEA chabot supportive in
Okay. So as I told, this can be either undergo elimination reaction, or it can be attacked by a nucleophile to form the product. Okay. So I know that now. I know the relative stability of this intermediate. Now let's see for the second one, what is the carbocation form. So here also I am removing the halogen. So in this case CH3, CH3, and with the positive charge. Now you can see here there are two CH3 group actually donating electrons to the central positive carbon, and we know that hydrogen has an inductive effect, that is 0. So now tell me which one is more stable reaction intermediate, the first one or second one? So in the first one there are 3 CH3 group actually stabilizing the reaction intermediate by pushing the electron towards the positive carbon, but in the second one only 2 CH3 group is doing. And if you go to the third one, you can see here CH3, CH2, okay, CH2 plus. So here you can see that only one ethyl group is only pushing the electron towards the central positive carbon. So the most stable reaction intermediate is formed by the first one. So since the first alkyl halide is forming the most stable reaction intermediate, that means this one most stable step is formed by the first one, then the first one will jump to reaction intermediate very fast, then it will move to product very fast. So I can say that the first alkyl halide, that is which one? CH3, CH3, CH3 and CH3X will react fast. So what is the reason? Very simple, because the reaction intermediate formed by this particular alkyl halide is most stable. Okay. So very simple, whenever you are given alkyl halides and they are asking you to compare the reactivity, what you need to do is form the reaction intermediate immediately and compare the stability and say that which one is more stable, identify which reaction intermediate more stable, then the alkyl halide corresponding to that particular reaction intermediate will react very fast. Okay, this is the conclusion. So I hope this application is clear for you. Okay, now I think we can go to the fourth next application. So here what sort of reaction is happening here? So you know that here a nucleophile is coming here. X is replaced by a nucleophile, correct? So X is replaced means it is a substitution reaction. Since a nucleophile is replacing it, I can say alkyl halides mainly undergo what sort of reaction? Nucleophilic substitution or elimination. Okay, so I can say the characteristic reaction, that is also important whenever you learn next year. Characteristic reaction of alkyl halides is NSR, nucleophilic substitution reaction. Most often it will undergo nucleophilic substitution reaction. In some 30 to 20% it will undergo elimination reaction if the nucleophile is not available or based on the reaction medium. I hope it is clear for you. Maybe we will do some questions for making you understand. I think the example question itself is sufficient. Okay. Okay, I will give you one more example question for your understanding. So let's see the question here. So you are given alkyl halides like CH3, CH2, Cl. Okay. The other one given is NO2, CH2, CH2, Cl. Okay, and you are given NC cyanide, CH2, CH2, Cl. You are given three alkyl halides, and you need to say among the three. Okay, this is first one, this is second one, and this is third one. So among these three, which alkyl halide will react very fast? Okay, to see the reactivity, so what is the step one? I can choose another color. So what is the step one? Step one is formation of Ri, reaction intermediate. So let's take the first one. So here when chlorine is moved out, so if chlorine is breaking, so what will happen? CH3, CH2 plus will be formed. This is for the first one. Now for the second one, what is the reaction intermediate? You have NO2 connected, then CH2, then CH2, and chlorine is removed. So this means CH2 plus will come here. Now for the third one, you could see here also chlorine is removed. So what will happen? NC cyanide is there, CH2, CH2 plus. Okay. Now you have formed the reaction intermediate. The next step is what? What is the step 2? Can you tell me? So step 2 will be comparison. Comparing what? Comparing the stability of Ri, reaction intermediate. So I will compare the stability of reaction intermediate. So on comparing, tell me first one here, what group is connected? You can see here CH3 group is connected, and CH3 group has what effect? Plus I effect. So this will push electron in this direction, correct? So the plus charge in the CH2 plus will get neutralized, making it stable. Now in the next one, you can see NO2 group is connected. So NO2 group means it has what effect? Plus I effect or minus I effect? I know it has minus I effect, so that electrons are attracted in this direction. So if electrons are moving in this direction, means here the positive charge will keep on accumulating, increasing. Now if you see the last one, that is a cyanide group is connected. Okay, see from the right to left, it is cyanide. So it is also having minus I effect. So electron will move in this direction and positive charge will keep on increasing this point. Now question come here, sir, in the second option as well as the third option, both are minus I effect. So how do we compare? So I can say that NO2 group has more minus I effect than the cyanide group. Now what is then which intermediate is more stable? So you can see that in the first option is more stable. Why? Because CH3 has plus I effect, that is pushing the electron to the plus charge, so thereby neutralizing the positive charge. But if you see the second and third option, both are unstable because NO2 and cyanide group has minus I effect, right? So out of this, most unstable is second one, because that is attracting the electron maximum towards its side, so that the CH2 group has more amount of positive charge. So I can say most unstable. Now if you see the third option, cyanide, you know it has minus I effect, so but less minus I effect compared to NO2, so this is also unstable. So tell me which one will be more reactive. So step 3 means what actually? So step 3 means the alkyl halide which has the most stable carbocation will be the most reactive. So which is having most stable carbocation? The first one. So I can say reactivity order is what? Tell me. First one more reactive, then who is the next most reactive? Third one, correct, because it is unstable, and the most unstable is the second one, so that is the least reactive, second one. So I hope you got a fair idea how to attend the questions coming out of this nature. But I am telling one more thing here. Here I have used inductive effect to predict the stability of carbocation. Sometimes they will give you an alkyl halide where resonance may come into picture, or hyperconjugation may come into picture. Here hyperconjugation is there in the first one, but I will teach you thereafter. Then we can use the priority wise. First resonance needs to be applied, then hyperconjugation, then inductive effect. Hope this application is clear for you. We will go to the next application. Okay. So I can give the heading, the fourth application. Okay, the fourth application is the inductive effect can be used to predict the reactivity of carbonyl compounds. Okay, so I will write here the I effect, inductive effect is used to predict the stability of, not the stability, predict the reactivity of carbonyl compounds. Okay, so you know that in the plus 2 chapter, the first chapter you have already learned haloalkanes, how to predict the reactivity, and you know what sort of reactions it will undergo. Now you got an idea. Now the next chapter, what you are going to learn in plus 2 is the aldehydes, ketones, and carboxylic acid. All these have carbonyl group. Now I am going to say how to predict the reactivity of these carbonyl compounds. Then it becomes, you will get a fair idea how to see predict that. Then you can use the same concept in that chapter as well. Okay, so let's see how to do that. So I will take a new color. Okay, now let me take an example so that you will get a fair idea. So I am taking a carbonyl compound like an aldehyde, CH3C double bond OH. Okay, so you know that it is an aldehyde, correct? So you can see a carbonyl group is present here. Now, if you analyze this carbonyl group, you can see that carbonyl group is formed between carbon and oxygen, and there is a double bond out there. Okay, since double bond is there, I can say the most commonly it will undergo addition reaction. Addition reaction is a reaction where the unsaturated compound will get converted to saturated compound. So here the double bond will get converted to single bond. Okay, now you know that it is addition. Then a question will come here, sir, whether it will undergo nucleophilic addition, that means a nucleophile will come and attack first, or whether it will undergo electrophilic addition, that whether an electrophile will come and attack first. This like doubt may come. So earlier I have told you in a haloalkanes, carbon halogen bond electronegativity difference is there, so it is very easy to replace the halogen. So I told the base reaction is substitution. And I told since positive charge is formed in the carbon, I told always the positive charge will be loved by a negative charge. That is a nucleophile. So I told substitution, who is substituting it? Nucleophile. Then I told the characteristic reaction of alkyl halide is nucleophilic substitution reaction. Now similarly, when I am observing the carbonyl compounds, I could see there is a double bond between carbon and oxygen. So surely since double bond is there, then the type of reaction will be addition reaction. Now the next question is, who will come and add? Whether an electrophile will come and add, or whether a nucleophile will come and add. Let's analyze that. Then we will come to a conclusion. Okay, let's see. Now on analyzing this carbonyl group, I could understand that in carbon-oxygen bond, for example, C double bond O, this is carbon-oxygen bond. I know that oxygen is more electronegative than carbon. So what is the effect of being more electronegative? Oxygen will attract the weak electron towards its side. I know that a double bond is formed between a sigma bond and a pi bond. And sigma bond, you know, it's a strong bond, and pi bond, it's a weak bond. So because of that, oxygen being more electronegative, always this pi bond will polarize towards oxygen. And what will happen? This pi bond will polarize in such a way that this will become minus charge for oxygen. Carbon will become positive charge. Okay. Now you could see this difference here. Okay, so now a question will come here. Sir, there is positive charge in the carbon and negative charge in the oxygen atom. So I can think like whether an electrophile can also come. Electrophile means with the positive charge. So positive charge may come near to this oxygen. Or there is a possibility like a nucleophile can also come, which is having a negative charge. So it will come to the carbon. So there is two possibilities are there, right? So how come we say that whether it is nucleophilic addition or electrophilic addition? This is the most common doubt put forwarded by students. Now please analyze this polarized carbonate group one more time. You can see here oxygen is carrying a negative charge. That means that we already know oxygen has 6 electrons. Okay, so when 2 electrons from this bond is also coming to here, so totally now it has 8 electrons. So that means the octet of oxygen is almost what actually full. So whether it will attract then a further an electrophile, there is less chance. Here at this point oxygen is stable. But if you look at the carbon, you can see, if you see here, carbon has one bond connected to another carbon and another bond connected to hydrogen, and one is connected to oxygen here. Now you see here carbon has 2, 4 and 6 electrons. There are 2 electron deficient. So surely if nucleophile is there, it will attract the nucleophile first. So I can say that nucleophile will be attacking this species first. So I can say nucleophile will attack the species first. Now tell me what is the type of reaction it is undergoing. I know it is addition. So who will come and attack first? Nucleophile. So I can say the characteristic reaction is nucleophilic addition reaction. Very simple. So you have learned. So in aldehydes, ketones and carboxylic acid, you can easily say so the characteristic reaction is nucleophilic addition reaction. Always the carbonyl group polarize, so that minus charge will come to oxygen, plus charge will come to carbon. So first the nucleophile will come and attack the carbon, then the electrophile may attack the oxygen. This is the common reaction that can happen, correct? So as I told, this will be happening here also. You can see here CH3, and this will polarize. Okay, so here plus charge will come, here minus charge will come, and here hydrogen atom. Now our purpose is what actually? I need to apply inductive effect here to predict the reactivity of this alkyl halides. So how it is possible? I will tell. Now you know that who is going to come and attack this positive carbon? Nucleophile, right? So a nucleophile with a minus charge is ready to come and attack here, correct? Now I know that nucleophile loves what actually? Positive charge, correct? So if the nucleophile want to attack this positive charge very fastly, what you need to give? You need to give more positive charge so that nucleophile can come and attack very fast, correct? Because if the magnitude of the charge is increasing, as you learned in electrostatics, you know that by Coulomb's law, the force of attraction F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So magnitude of the charge is very high, means the force of attraction will also be very high, correct? Now I can say that near to this carbon, you could see here there is a CH3 group connected, and also there is another hydrogen connected, and I know that this CH3 group has what effect? It has plus psi effect, correct? So because of the plus psi effect, what is the impact? This CH3 group will repel the electron away from it. So that means it keeps on pushing the electron to central positive carbon. Now what is happening? Electrons are negative charge. When it comes to the central positive carbon, the positive charge in the central positive carbon diminishes or decreases. Now tell me whether nucleophile will have any interest to come over there. Nucleophile will come, but the intensity will be very less. That means I can say that here the plus psi effect of CH3 group is decreasing the reactivity of what actually? This particular aldehyde. Understood? I hope you got a fair idea. Now we will try to see with some examples how it is happening. Okay. So I can conclude saying like plus psi effect group present near to carbonyl group decrease the reactivity, okay, decrease the reactivity of carbonyl compounds. Okay, so now what will be the opposite then? Think like you have a minus I effect group is connected there. Surely it will attract the electrons and the positive charge on the central carbonyl carbon keep on increasing. That means it can be easily attacked by the nucleophile. So I can say the reverse is minus I effect group, minus I effect group present near to present near to carbonyl group, present near to carbonyl group, increase the reactivity, increase the reactivity of carbonyl compounds, carbonyl compounds. Clear? So you got a good conclusion here. Now let's try some questions with this idea and check whether you are understanding it or not. Okay. So starting with the question 1. Okay. So let's see one question applying this concept. So you are given some aldehydes. For example, you are given the first compound as CH3, C double bond O H. This is acetaldehyde, you know. You are given next aldehyde like FCH2, C double bond O H, and you are given a third aldehyde like this Cl CH2, C double bond O H, correct? And you are given a fourth aldehyde like this CH3, not an aldehyde, a ketone, CH3, C double bond O CH3. So these 4 are given and you need to predict the reactivity order. Which one is more reactive, and you can write it in decreasing order of reactivity. Okay, let me take it one by one and analyze it. Then only I can say that, correct? So the first one I am taking, that is acetaldehyde CH3, C double bond O H. Okay, so if you are doing it initially, what is the first step you are expected to do? Polarize the carbonyl group, because you know every time it will be C double bond O, again it is polarizing, again it will form double bond, like that it keep on changing like that. So let's polarize that CH3, then CO minus, and this will become positive charge and this will become hydrogen. Now analyze this positive charge. Check whether this positive charge is getting increased or decreased. So I know that near to that CH3 group is present. So this is having what effect? Plus I effect. So this will donate electrons. So that means positive charge is decreasing. So that means reactivity is, what will be happening to reactivity? Reactivity decreases. Why? Because the nucleophile, that is incoming nucleophile, always loves positive charge. The purpose of increasing reactivity, if you want to increase the reactivity, the positive charge should increase. Somebody nearby should increase the positive charge. Actually here decreasing is happening. So I can say this has generally less reactivity. Now come to the next one, second one. So there you have FCH2, C double bond O H. So here also I am polarizing it, F, then CH2, then this will become O minus, and this will become plus, and you have hydrogen here. Now you could see here, since fluorine is connected, so what is the effect of fluorine? You know that fluorine has minus I effect. That means electrons are pulled in this direction. So electrons are pulled towards fluorine, means the positive charge here increases. That means the attack by nucleophile will become very easy. That because minus I effect group is connected. So I can say the reactivity, what happens to the reactivity? Increases. Correct? Now let's take the third one and analyze. Okay, where the chlorine is present. Okay, so chlorine, CH2, C double bond O H. So if you see here also I am polarizing Cl, CH2, C, O minus, and hydrogen is present. So here with positive charge. Now you know that chlorine also has minus I effect. So I can say chlorine has minus I effect. So electrons are pulled in this direction. So positive charge here increases. Now a comparison will come. Sir, in the second one and third one, same thing is happening. So where it will be more reactivity? I know that fluorine has more minus I effect than chlorine. So surely who will be reacting very fast? The second one will be reacting more very fast than the third one. Okay. Now we will go to the last one. So I can generally say here also the reactivity, what happens to the reactivity? It is increasing, but here it is increasing more. So I will put two arrows here. Now comes to the last one where you have an acetone CH3, C double bond O CH3. Now tell me, analyze this. You could see here CH3, this is becoming CO minus and this is becoming plus, and here you have CH3. Now you know that two CH3 groups are connected. So what is happening basically, this is having plus I effect. So this will donate electron to this side and this is having what effect? Plus I. So this will also donate electron to here. Okay, if both are donating electron to the central positive carbon, positive charge will disappear, correct? So I can say the reactivity decreases. Reactivity decreases very fast. Now, this is one logical reason you can say that, sir, reactivity of aldehydes are much higher than ketones, because in ketones, near to the central carbon, carbonyl carbon, you have more alkyl groups are there. That will reduce the magnitude of the positive charge on the central positive carbon. Because of this, the attack by nucleophile will be very less. So I can say, sir, aldehydes are more reactive than ketones. Now tell me here, what will be the reactivity order? So now you got a fair idea what will be the reactivity order here. So I know that more minus I effect is for which one? Out of this fluorine. So fluorine, it is connected to, option is second one. So I can say second one is more reactive. Then who is more reactive? Then chlorine. Then I can say chlorine is third one. Then which one is more reactive? Last one means two CH3 groups are there. First one means only one CH3 group is there. So then first one. Then comes the fourth one. Okay. So I hope you got a fair idea how to use inductive effect to predict the stability of or to predict the reactivity of carbonyl compounds. And now you know that the characteristic reaction, that also I will write, the characteristic reaction given by carbonyl compounds is what actually? I can say NAR. NAR stands for nucleophilic addition reaction. Is that clear for everyone? Okay. Now let's see the next application of inductive effect. So many applications are there. We need to go through that one by one because all these applications comes as questions for your NEET exam. Okay. So let's see. So we have learned 4 applications. I'm going to the 5th application. So I can give the heading now. The 5th application. Okay. So what is the 5th application? Okay, the 5th application here is you can predict the acidic nature or acidic order of carboxylic acids using inductive effect. So I can say acidic strength can be predicted. Acidic strength can be predicted by I effect, inductive effect. So let's see how to do that. Okay. Okay, first of all, before I am going to explain that, let me tell what is basically an acid and how you say whether the given compound is a good acid or not. Okay, then you will get a fair idea how to do that. Okay, so let's start with an analysis. So I can say an acid an acid is basically a proton donor. Proton donor. So what is basically a proton donor? That means H plus donor. Correct? H plus is a proton. Okay, there are many definitions you could see in the chapter. What do you say? Ionic equilibrium, as well as in chemical bonding with respect to acid, how you define basically an acid. So we will take here the basic definition as an H plus donor, or the other one is, I can say, we can say electron acceptors. Electron acceptors. Okay. So this is the basic definition. Either you can use the definition H plus donor or electron acceptors. And what is basically a base? How you can define a base? A base is an OH minus donor who can donate hydroxyl ion, OH minus donor. Or we can say the other way, they are okay, electron donors. Okay, who can donate electrons, they are also called base. So acid is an electron acceptor and base is an electron donor basically. Now with this definition, let me say how to predict how inductive effect is going to do a role in predicting the acidic strength of a particular compound. I will tell one analysis, then just analyze that and check whether you are understanding or not. Okay, so let's see that. So suppose you are given a compound. For example, something like CH3 COOH. This is a carboxylic acid. Now I know that to say the acidic strength, the step that I used to follow here is, or not, generally in chemistry what we follow is, first step is donate the H plus. If it has an H, then donate it as H plus. Okay, and always remember, donate the H from donate the H from a bond which is a polar bond. That is very important. Don't donate the H from CH3. Not possible, because carbon and hydrogen, they are not having sufficient electronegativity difference. So donation, the bond breaking is not that easy. But here if you see OH bond, which is a polar bond, oxygen and hydrogen, there is sufficient electronegativity. So it is a polar bond, so that can be broken very easily. So we say first step is donate the H plus. That is donate the H plus. Okay. So once you donate the H plus, what will happen here? You will get CH3, COO minus and H plus. Now the second step, what you need to do is just to think like this. If the structure after donating the H plus, what is the structure after donating the H plus? This one, correct? This is the structure after donating the H plus. So if this structure is stable, if that structure is stable, then I can say that the compound the structure which donated the H plus will not attract the H plus back. That means it is a good acid. So I can say the conclusion like that. If this is stable, what is that meaning? If that is stable, then it will not attract the donated H plus. So if it is not attracting the donated H plus, means it has donated an H plus. If somebody who donates H plus, then it is a good acid. Then it is a good acid. Okay. So it depends upon the stability of the remaining structure. So suppose thing like the remaining structure is not stable, then what will happen? It will attract the H plus. Correct? Okay, I can give you an example, but okay, right now not needed. So okay, now let's compare it so that you will get a fair idea. We will take different compounds and see. So we will handle this with a question. Note down the question. Question is predict the acidic strength of given carboxylic acids. Given carboxylic acids. We will see that. Okay. So suppose you are given the first compound like CH3, CH2, COOH. This is the first compound given. Then the next one given here is Cl, CH2, COOH. Then the last one given here is F, CH2, COOH. These three compounds are given. Now you need to say out of the given three compounds which is having or which is a good acid, or you can write it in decreasing order of the acidic strength. Okay, so let's start analyzing it, then you will get a fair idea how to do the analysis. So the first compound I am taking is CH3, CH2, COOH. So what is the first step you are expected to do? Donate the H plus, correct? So on donating the H plus, this will become CH3, CH2, COO minus and H plus. Okay. Now you know that there is minus charge in the oxygen atom. I need to predict the stability of this carboxylate anion by resonance or inductive effect or hyperconjugation. Since we are learning inductive effect, I will predict first that. Based on that, I will explain. Okay. Now I know that near to this carboxylate ion, which group is connected? CH3, CH2 group, which is an alkyl group. So alkyl group has what effect? You know that it has plus I effect. What plus I effect will do? It will push or repel the electron away from it. So that means electrons are moving towards the central carbon or towards the oxygen atom, which is already having negative charge. So what is basically happening because of this? I can say the result is electron density of oxygen atom increases. Oxygen atom increases. Now tell me, if the electron density on the oxygen atom is increasing, what it will try to do? We know that if the magnitude of the negative charge is increasing, it will try to attract the opposite charge, that is H plus. Then it will keep on attracting the released H plus. That means the acidic strength is lower, correct? Generally lower. So I can say increases. As a result, it will try to attract the H plus back. That is, it is not a good H plus donor. That is not a good H plus donor. Okay. Just all these are relative comparison. So I can say this is the first conclusion. Now let's take the second one. So in the second compound you have Cl, CH2, COOH. So what is the first step you are expected to do? So release the H plus. So this will become Cl, CH2, then this will become COO minus plus H plus. Now you know that you got the structure. Now I need to analyze the stability of this structure. I know that chlorine, it has what effect? So it has minus I effect. So chlorine is having minus I effect means it will attract the electron towards chlorine. Correct? It will attract the electron towards chlorine. So electron will come towards the chlorine atom. You could see the arrow direction. So if electrons are moving from oxygen atom towards the chlorine atom, that means what? Actually, it is very good. You are removing the negative charge in the oxygen atom. This means we are removing the negative charge on oxygen atom. So if you remove the negative charge on the oxygen atom, it is becoming what actually? Stable. Becoming stable. So that means if it is stable, will it attract H plus? No. So this will not attract H plus. If it is not attracting the H plus back, that means it is a good donor of H plus. So what is the conclusion I can say? It's a good donor of H plus. That is a good acid. Or I can say its acidic strength is very high compared to the previous acid that we have seen. Now let's see the third one. So in the third one, you can see, now you know how to do it. You have where fluorine is getting connected. So fluorine with CH2 and COOH. So here also again the first step is what actually? Removing the H plus. So you will get FCH2 COO minus. Correct? Now I know that fluorine has what effect? A very good minus I effect is there. So electrons will move towards the fluorine atom. So that means what actually? It is becoming more stable. It is becoming more stable. That means more stable means it will not attract the H plus back. That is, it is a very good acid. Very good acid. Now if you compare the second one and third one, they are chlorine and here fluorine. Who is having more minus I effect? Fluorine. So that means that will attract the electron very fast and making it more stable. So good acid is which one? I can say the order will be the first one will be C, then B, then A. So I can write here the conclusion. Order of acidic strength. Order of acidic strength. Okay. So first one will be C, will be great good acid, then B, and then only A will come. Correct? So C will come first, then B, then A. So I hope that is clear for you how to predict the acidic strength using the inductive effect. So I have explained it as best as possible from my side. So we need to do more questions actually from this side, because this is from this area you will get repeated questions of different types. So we will practice some questions and then we will go to the last application that is used to predict the basic strength of the compounds.